The table shows Amazon's annual revenue in billions of US dollars for the years 2015 to 2021. And the first part of this example asks us to create a scatter plot of the data with X equal to the number of years after 2014. And then once we do that, to find the quadratic function that best fits that data. So we're going to do this in the graphing calculator, and we just want to start by entering our data into the calculator. So on the graphing calculator, I'm going to go to Stat and then go into Edit to edit my data. I'm going to start by clearing out any old data that's in here. So I'm just going to arrow up to where L2 is highlighted, and then don't hit delete, but hit clear and then enter, and that should clear out that list. And I'm going to do the same thing with L1. Clear and enter, and then I'm going to just start putting this data into L1 and L2. In this case, it said X should equal the number of years after 2014, and the first year listed here is 2015, which is 1 year after 2014. So that means my first X value is going to be 1, and then 2016 would be 2 years, and so on. So I'm just going to enter in my values here for X, or the number of years after 2014. And then in L2, I'm just going to go ahead and put in the revenue, and I'm not going to put this in billions. I'm going to put it in just the way they have it. Then I'll remember that that's in billions. All right, so once my data is entered, I want to go ahead and create a scatter plot of that data. So just as a check, I'm going to go to y equals and just check that there's nothing in here right now. So if you have any equations in there, you want to clear them out first. And then stat plot is actually the y equals button, but you have to hit second. So I'm going to hit second and then that same button to go to the stat plot. And then right now my plot is off, so I just want to change that into the on position. So while that first plot is highlighted, I'll hit enter. And then when it's flashing over the on, I'll hit enter, and that will toggle it from off into the on position. So that's really all I need in order to make a scatter plot, is just to enter my data and then turn the plot feature on. However, if I hit graph right now, I'm likely not going to see my points here because I'm just not zoomed to the correct section of the graph. So you can set your window manually, but you also have, if you go to zoom and scroll down to the zoom stat option, that automatically zooms to wherever your points are in a scatter plot. So I'm going to choose that option, and then this should be the scatter plot of my data. So we've done linear regression before, which is where we try to fit a line to our data, and I could probably do that with this data. This data is pretty close together, and I could probably find a reasonably good fitting line that gets pretty close to a lot of those data points. However, I am seeing a slight curve in this data, and so even though a line may work pretty well, a curve such as a quadratic or a power model may work even better. And in this case, they're actually specifying that they want us to find a quadratic function that fits that data. So I'm going to have the calculator do that by going to Stat, and then I'm going to arrow over to Calc. And when I did this to find a line that fitted, I chose a linear regression option, so like option 4 or option 8. In this case, though, I want to find a quadratic function, so I'm going to choose quadreg, which on mine is the 5th option, which just stands for quadratic regression. So I'm going to hit enter. And then as long as your X list is already set to L1 and your Y list is already set to L2, you can technically just hit enter until you get your equation here. However, I'm gonna also want to graph this equation, and so to kind of save you a step later, what you can do is if you go down to the line where it says store reg EQ, that is basically where you can tell it where you want it to store the equation it's going to calculate. So it's going to calculate it either way, but on this line, I'm going to go to vars, which stands for variables, and then over to yvars or y variables. I'm going to choose function, and then I'm going to choose y1. And then that's just telling it that, hey, this equation that you're going to calculate for me, I also want you to store it in y1, which means that once I do this, it'll be in my y equals automatically, and then that way it'll automatically graph it for me. So that was the step I did there, and then I'm just going to hit enter a couple times until it calculates this, and there's my quadratic equation. So it's in the form y equals ax squared plus bx plus c, but it tells me what a, b, and c are. I'm going to just choose to round these to 3 decimals, and instead of y, I'm going to write this as f of x, but it's the same thing, right? F of x equals ax squared, where a is 6.871, plus bx, so this would be plus 5.429x, plus c, which is 96.6. So there's the equation of the quadratic that fits my data. And then since I already told it to store that in y equals, I'm just going to hit graph, and it should graph that curve for me. So I can see this is basically part of a parabola. And does it fit my data? Absolutely. This fits it pretty well. It actually seems like it goes through a lot of those points and gets very, very close to the other one. So even though a line would have probably fit this, this curve seems to fit even better. Now, once I have this, I'm ready to answer part C. Part C says to use the model to find the year in which Amazon's revenue is projected to reach 850 billion. So the revenue we know is the Y value in this case. So it's really just asking me, like, find the year, or in other words, find the X value when we get to a Y value of 850. So there's a couple ways that I can do this, and it just depends on whether you want to just approximate an answer, if you want to get an exact answer. If we're not worried about getting an exact answer, we can actually just use the table function of the graphing calculator. So what I would do is I would go to table, which is second, and then that graph button. And then basically I'm looking for a Y value of 850. So I would just scroll through this looking at my Y values, and you're not going to find exactly 850, but eventually you find pretty close, right? And so I can basically see that 850 would be somewhere in between an X value of 10 or an X value of 11, right? So that would be 10 to 11 years after 2014, since that's what our X value stood for. So that gives me a pretty good approximation. However, if you want to do this exactly, you can actually have the calculator do it exactly as well. So what I'm looking for is, when is my Y value going to reach 850, right? Because the Y value was the revenue in billions. So I can go to Y equals, and I want to keep this equation in here. This is the equation that I calculated in part A that it automatically stored here for me. But then what I can do is I can go down to Y2 and actually just put in that Y value of 850. So now if I go to graph, this may not show up. I may need to actually zoom out to see this. So I'm going to go ahead and do that. I'm going to go to zoom and then choose zoom out. And in order to zoom out, once you get back to the graph screen, you have to actually hit enter, and then it will zoom out. So we can see actually that what we were seeing with our points is really only part of this parabola, part of this model. And then that red line that's going across, that is the line I put in 850. So when they're saying use the model to find the year in which Amazon's revenue is projected to reach 850 billion, they're really saying this blue model, this parabola, this quadratic curve that I have, when is that model going to reach that red line at 850? And so I can have the calculator actually calculate the intersection of my blue parabola curve here with that red line at 850 billion. So to do that, I'm going to go to calc, which is second, and then the trace button, and I'm going to choose intersect. All right, so I want it to calculate the intersection. So it's asking me at the bottom here, it says, where is your first curve? So you can move the arrow buttons left and right if you like, but really you don't necessarily need to, as long as you're anywhere on that parabola, that's your first curve. So just hit enter. And then it wants to know where is your second curve, and as long as you're someplace on that line is my air quotes curve, right? My second curve. So anywhere on that line, hit enter. And then it wants you to guess, and so that just means you move as close as you can to where they actually intersect, and then hit enter, and it will calculate this exactly. So we had said when we used the table that this was an X value in between 10 and 11. This is exact, and it's telling me that actually it's an X value of 10.083465, and I'm sure that number keeps going. So that gives me an exact answer. So that means that in this case, it's actually 10.08, and X was the number of years after 2014. So this is 10.08 years after the year 2014, which would be like probably roughly around 10 years and 1 month, if you want to know exactly when that happens. They had said to find the year, so I need to actually find the year, but basically I would just take, 10 point something and add it to 2014. And so this would happen during the year 2024.